Hello students, welcome to my study channel Associative Property. So for example, you may take any negative integer, you may test it, or you may take any positive integer, that depends on you. But the format is same. You see, associative property or associativity so do the integers show associative property or they show associativity under addition? Yes? We will have to prove it. Suppose you will take three integers 2, 3 and 4. So 2 plus 3 plus 4 is equal to 2 plus 3 plus 4. Whether this is true or not, we will see. And you see, what is in the left hand side? 2 plus 3, this is the bracket for 4, that is equal to 2 plus 3 is equal to 5, 5 plus 4, that is equal to 9. So this is the left hand side. What is the right hand side? 2 plus 3 plus 4 is in bracket. So 2 plus 7, that is equal to 9. And you see, when we changed the grouping of numbers, here when one group was found, here it was 2 and it was 3. But in this group, here it is 3 and 4. So the grouping of numbers has been changed. But the sum is same. But we have taken the basic operation addition. So we can say the integers show associative property under addition. So I can give a tick mark here. Let us move to basic operation subtraction. Same 2, 3 and 4 we will take. 2 minus 3 minus 4 like this. Will it be equal to 2 minus 3 minus 4? We will see. And you see, 2 minus 3, that is inside the bracket. So we will do the work of the bracket first. So 2 minus 3, that means 2 plus of minus 3. So this is minus 1 and minus 4. That is equal to minus 1 plus of minus 4. What is the result here? Minus 1 plus of minus 4. Here you see both integers are of same sign. So this is minus 5. And now we will solve it. You see 2 minus 3 minus 4, that is equal to 2 minus 3 minus 4, that is 3 plus of minus 4. That is minus 1. That is equal to 2 minus into minus, that is plus 2 plus 1, that is equal to 3. So here it is minus 5 and here it is 3. So minus 5 is not equal to 3. So what we knew, the integers, they do not show the associative property under subtraction. So I give a cross mark here. I just erase it. Two into 3 into 4. You give a bracket here. Then you change the grouping of numbers like this. Yes. Whether you will see whether it is equal or not. Okay. I am not giving the sign, equality sign here. Just to see what is the value. Just we will have to simplify. that is equal to 2 into 3, that is 6 into 4, that is equal to 24. Here it is 2 into 3 into 4, 3 multiplied by 4, that is equal to 12. So 2 into 12, that is equal to 24. Same value. So it is true. So what we knew? All the integers show associative property under multiplication. Also we will test the division operation for the associative property, whether this holds good or not. You see, and whether it is equal to, we will have to prove. So let's simplify it. Okay, 2 divided by 3 into 4 means 4 by 1. 4 means 4 by 1. So what is the reciprocal? Because we change the division sign into multiplication, so it is 1 upon 4. So what is the final value? 2 1 is 2, 2 2 2 are 4. So 1 into 1, that is 1, 3 into 2 is equal to 6. So this result is 1 by 6. Here you can see 2 divided by 3 upon 4. That means 2 means 2 by 1 into, when you change the sign, so what is the reciprocal of 3 upon 4? That is 4 upon 3. That is equal to 2 into 4 divided by 1 into 3. That is equal to 8 divided by 3. So here the result is 1 by 6. If you tell it is the left hand side, then it is 1 by 6 or 1 upon 6 or 1 divided by 6, and in short form we also tell 1 by 6. So it is 1 upon 6, it is 8 upon 3. So 1 upon 6 is not equal to 8 upon 3. So integers, they do not hold good, they do not show associative property under division. They do not hold. So finally, what we can write? How will you remember? Already I have told you all the integers are closed under addition, subtraction and multiplication. Already you know that. And second point, you remember all the integers so associativity, that means associative property, associativity, VITY, and all the integers. So first to write commutativity and associativity under addition and multiplication. Okay, so you will remember, it will be easier for you. First point, all the integers are closed or show the closure property under addition, subtraction and multiplication, and all the integers show commutativity and associativity under addition and multiplication. You remember, this is most important. So I erase it. And there are also some more properties. We'll discuss. And you see existence of additive identity. Existence of additive identity. So what is additive identity? You see, for any integer, you take any integer and you add 0. 0 is a number, you add it, there will be no change in the number. That means if a is an integer, either you add 0 to a, you will get a, or you first write 0, then you add a, then there will be no change in the number. The same number is here. The same number, there is no change. So additive identity, 0 is called the additive identity. Always remember, it's very important. 0 is called the additive identity. So we may take an example. Suppose 6 plus 0, that is equal to 6. If you add 0 plus 6, that is equal to 6. If minus 6 plus 0, that is equal to minus 6. And if you add 0 plus or minus 6, that is also minus 6. So there is no change in the value, you may see. So 0 is called the additive identity. So I erase it. And add inverse of integers. Additive inverse of integers. So how you do it? You see, additive inverse. Inverse means just opposite. Additive, we have to add, and you see, suppose 5 is an integer. So what is the additive of 5? Now just you multiply minus 1 by that integer. So for 5, the additive inverse is 5 into minus 1. That is equal to minus 5. Bring that minus 5. You add, and the result is 0. The sum is 0. So you see, a number and its additive inverse. You add a number to its additive inverse. The sum will be 0. This sum will be 0. And you will have to remember it. If you add an integer to its additive inverse, the sum will be 0. So for any integer, if it is asked to derive the additive inverse, you will multiply minus 1 to that number and you will get easily the additive inverse of that integer. Okay? So let us know about the multiplicative identity. So there is the existence of multiplicative identity. For any integer a, a into 1, the product is a, and if you multiply 1 by a, then the product is a. There is no change in the integers. The same a is here. The same number is same integer is here. So one is called the multiplicative identity. Okay. So we will know about the multiplicative inverse. Or that is also called the reciprocal. Multiplicative inverse or the reciprocal. So if the product of two integers is 1, then they are reciprocal of each other. So the product of two integers, if this be 1, then they are reciprocal of each other. But most important is multiplicative inverse exists for the non-zero integer. So if a is a non-zero integer, then its, suppose am I right, multiplicative inverse exists. So the multiplicative inverse is 1 upon a. So how you see? Suppose a, we will write it a upon 1. The numerator is a and the denominator is 1. So you see, and if I reverse it, that is 1 upon a. So this is the multiplicative inverse of a. And you see a into 1 upon a is equal to 1. A means a upon 1. So 1 upon a is the multiplicative inverse of a, and a is the multiplicative inverse of 1 by a. Both are reciprocal to each other. Both are reciprocal of each other, and if you multiply a non-zero integer to its reciprocal or to its multiplicative inverse, the product will be always 1. The product will always be 1. So this is most important, and you will remember it. Let us focus on distributivity or the distributive property of multiplication over addition, and distributive property of multiplication over subtraction. These two hold good for integers or not? Yes, it is true. So distributive property of multiplication over addition. First we will take this. This holds good for the integers. Okay. So you see, let us take three integers a, b and c are three integers. So a whole into b plus c. that is equal to A into B plus A into C. You just say A whole into B plus C. There is no single integer here. B plus C. B is an integer, C is an integer. So B plus C, that is within the bracket. A whole into B plus C. Okay? That is equal to A into B plus A into C. So this is the distributive property of multiplication over addition. So let us take some examples. We verify it. Suppose A is equal to 2, B is equal to suppose 4, C is equal to 3. So you see, what is in the left hand side? A whole into B plus C. That is equal to, you see here, in place of A, you write 2 into sign of multiplication. Then you start the bracket. 4 plus 3. So we will have to solve the bracket first. 2 into 4 plus 3 is equal to 7. That is equal to 4. So what is RHS here? Right hand side. A into B plus A into C. That is equal to, what is A here? A is equal to 2. So put 2 in place of A into 4 plus A into C. A is 2 into 3. 2 into 4 is equal to 8 plus 6. So this one is 40. So you see, therefore, left hand side is equal to right hand side. So just we verified it. So it is the distributive property of multiplication over addition. Just I erase it. So distributive property of multiplication over subtraction. Just I change here. A whole into B minus C, that is equal to A into B minus A into C. Suppose A is equal to 2, B is equal to 4 and C is equal to 3. So what is the left hand side? A whole into B minus C, that is equal to 2 into, what is B? B is equal to 4, so 4 minus 3, that is equal to 2 into 1, that is equal to 2. So what is the right hand side? Minus A into C, that is equal to 2 into 4 minus 2 into 3. So 2 4s are 8, minus 2 3 is 6. 8 minus 6 is equal to 2. So therefore LHS is equal to RHS. So distributive property of multiplication over subtraction, that also holds good for the integers. Okay. So this distributive property or distributivity is very much important. So we will see some of its application, how these are useful. Suppose it has been given So we will apply some suitable property and we will find the product. You see. How will use the property? We may convert it into 100 plus 1 like this. So you see A whole into B plus C. That is the distributive property of multiplication over addition. We may convert it. It will be easier. That is equal to A into B plus, this is the plus sign, 98 into 1. And just to multiply, how many 2's are there with 1? Towards right you see there are 2 2's, 2 zeros, sorry. So you write plus 98. Then you add it. Here are the 2 digits. 0 0. So without doing the complicated multiplication, easily using the rule, we could solve it. But you will mark it when we converted 101 into 100 plus 1. And then we write this. So by you write distributivity, because we use this property. So just you will write here towards the, then we solve it. So this is helpful or not? Yes, this is helpful. Again you see, if I take another example, suppose that 98 into 99. So I'll have to write 98, then I'll have to multiply 99. Like this. This is a complicated method. No. We'll use the distributive property. How you see? 100 minus 1. Okay? That is so this is by distributivity. Then we subtract and write. So it is easy. Only one subtraction is needed to know the difference. So this property is very much useful. So I erase it. Suppose when we are writing A whole into B minus C or P plus C, whatever it may be. Suppose this is the distributive property of multiplication over subtraction. A into B minus A into C. And you see, we can also think if A into B minus A into C, we may write like this, A whole into B minus C. This was in the left hand side and this is in the right hand side. If I write this first, automatically that will be equal to A whole into B minus C. And how this is helpful, you see, because someone will tell, a 2 whole into 4 minus 3, we will do 2 into 4, minus 2 into 3, 8 minus 6, that is equal to 2. So what is the need of doing this? No. If you release the bracket and you write like this is also helpful. Where? When? Just we will mark it, you see. Just erase it. Let's take an example. 993 into 105 minus into 5. In this case, there is no need of multiplying these two integers. We will multiply these integers. Then we will subtract. Do not do this. Use this property. How? That is equal to 993 into 105 minus 5. A is equal to 993 and B is 105 and C is 5. You see. A into B minus A into C, that is A whole into B minus C. So this is the answer. So it is very much helpful. So this is the distributive property of multiplication over subtraction. So distributive property of multiplication over addition, over subtraction hold good for integers. So I erase it. Let me discuss one thing with you regarding the integers. You see, when two integers of same sign are multiplied, the product will be positive. Suppose simply we write 2 into 3 is equal to 6. 2 is a positive integer, 3 is a positive integer. You see, the product 6 is a positive integer. Minus 2 into minus 3, that is equal to 6. Both the integers, they are with same sign. So if the integers of same sign are multiplied, then the product will be a positive integer or it will be a positive number. Always remember this. So this is most important, you will have to remember. Then if the integers of opposite signs are multiplied, the product will be a negative one. You see, suppose 2 is positive integer into minus 3. So you see, the integers of opposite sign, here it is the plus sign, we have not written, it is not, generally it is not written, so it is a positive integer. So 2 into 2 multiplied by minus 3, that is equal to minus 6. And if I write minus 2 into 3, that is also minus 6. You remember this. And in short, what we do? This is the plus sign. Plus sign. Minus. You should remember this. This is most important. Okay? I erase it. And in your NCERT book, product of three or more negative integers you know the negative integers. So product of 3 or more negative integers, that means you see, if the number of negative integers, so negative you may write like this in short form, it is also used like this. So if the number of negative integers in a product is even, then the product is a positive integer. Then the product is a positive integer. So you know what is even and what is odd. So a even number, that means that number is completely divisible by 2. That is a multiple of 2. And odd number you better know, which is not completely divisible by 2 or which is not a multiple of 2. So you see, suppose I will write like this. Anyhow, I have to write the product here or not? But what sign it will bear? What sign will be with the product? So you see, 1, 2, 3, 4. How many negative signs are here? 4. So you see, if the number of negative integers in a product is even, number of negative integers, how many? 1, 2, 3, 4. So the product is a positive integer. Just you remember it. You do not do like this, minus into minus plus, then it will be plus into minus minus, then minus into minus plus. No. No such. Just you count how many negative integers. That means you just count the negative signs. 1, 2, 3, 4. It is even. So the product will be positive number. Then you multiply the numerical value according to the associative property. After 2, then third, then the fourth one, like this. So you will get the numerical value, but the sign will be a positive sign. It will be a positive integer, the product. And if the number of negative integers in a product is odd, definitely there will be the negative sign. Okay? Suppose like this. Suppose. So here will be the numerical value of the product, but what will be the sign with it? You see 1, 2, 3. So definitely this will be minus answer. And finally, let it be 30. Yes or no? Ultimately, the product is minus 30. So this minus sign is why? Now you see the number of negative integers, negative signs are 3, and we are multiplying. So you should remember this. So overall, I have completed the integers what you have in your NCERT book, and in my next videos I will solve the exercise questions part wise, mentioning the exercise. I will solve and I will send through the video clips, so you will follow it. So thank you for joining the study channel. Wish you all the best.